Bismillahirrahmanirrahim. Welcome to the second part of this lecture. This lecture in which we are going to speak about the representation of the function as a power series. And in this part, we are going to speak about the differentiability and integrability of the function if it is written as a power series. Starting with this theorem, say that if the power series c sub n times x minus a to power n has a radius of convergence r greater than 0, then the function f defined by power series f of x equal to sigma of cn times x minus a to power n is differentiable. Differentiable means that we can differentiate the function. So f prime is equal to, this one is 0. So start with c1 times 2c1 x minus a plus 3c3 x minus a to power 2, or is this equal to, as a power series, sigma n times cn times x minus a to power n minus 1, where n starts from 1 to infinity. So we are differentiating the term inside the sigma, or we can say an. Also, it is integrable. So the integration of f of x dx equal to c, because this is indefinite integral, so we have to have this constant c. Then we are integrating the term of the function one by one. So we'll have c plus sigma, and the integration of this term, x minus a to power n, we just apply the general rule for integration. That will be x minus a to power n plus 1. We are adding n or 1 to the power and divided by the power n plus 1. And we have also one remark that the radius of convergence of the power series in equation 1 and 2 are both equal to r. It means that the radius of convergence will not change after differentiating or after integration. It's similar to the radius of convergence of the original function. For example, let's find a power series representation for the function, and also we need to find the radius of convergence of the function f of x equal to x divided by 1 plus 4x to power 2. Since I have this power, we can think about the general form I have. The general form is 1 over 1 plus x. And I need to find the relation between this function and this one. That is 1 over plus 4x to power 2. So the function f of x can be written as x multiplied by 1 over 1 plus 4x to power 2. But 1 over 1 plus 4x to power 2. If we can just, I need to think about the differentiability of the function. I know that 1 over 1 plus 4x, or the derivative for this one, is equal to, down I will have 1 plus 4x to power 2. So we got the power there from the derivative. For the numerator, it is minus 4. So the derivative of 1 over 1 plus 4x is equal to minus 4 over 1 plus 4x squared, or I can write it as minus 4 times 1 over 1 plus 4x to power 2. I have 1 there, and this is 1, but I have this coefficient minus 4. So to make it minus 1, I will divide by minus 4, which means this function will be equal to x multiplied by, because I need to have minus 4 there. It is minus 4 multiplied by 1 over minus 4. It means that this function, or what I need just to divide by minus 4. Since I have minus 4, To get it 1, I will divide by minus 4. So it is minus 1 over 4 multiplied by the derivative. The derivative is given by minus 4 times 1 plus 4x squared. So if we divide by minus 1 over 4, is to keep this one there. So multiply by minus 4 and divide by minus 4. Then I will have x, or we write it as minus 1 over 4, and it is minus 1 over 4 multiplied by x times the derivative of 1 over 1 plus 4x squared, or just 4x, sorry. Again, this one is the derivative of 1 over 1 plus 4x. So I will have minus 1 over 4x multiplied by, I will write this one as power series. It is sigma, or I forget to write the derivative, it is d by dx of sigma 4x, it can be written as minus 4x to power n to infinity. So it is minus 1 over 4 multiplied by x, can be written as minus 4 to power the derivative d by dx minus 4 to power n times x to power n. Now, if I want to differentiate it is d by dx, how I want to differentiate this term, I will get minus 1 over 4x times minus 4 to power n times x to power n minus 1. Multiply x by this one, we'll have minus 1 over 4 sigma minus 4 n x to power n. There's no enough space for this one. I will write it down is equal to minus 1 over 4 sigma minus 4 to power n times n x to power n. But this is x to power 1 and this is n minus 1. We add the powers together, I will have x to power n, or I can write it as minus 4 to power n minus 1 times n times x n minus 1, where n starts from 1 to infinity. So this is the power series representation for the given function. We apply the derivative of the power series or of the function to write the representation for the given function. And to find the radius of convergence, we can apply the ratio test. Another example, f of x equal to ln 5 minus x. Now 5 minus x, the question will be how this is related to the function 1 over 1 minus x, because as we say that this will be our k for the power series, 1 over 1 minus x. Now, ln of 5 minus x, how this is related to this one? But we know that ln of 5 minus x is the integration of 1 over 5 minus x dx. So on what I need to write it as 1 over 1 minus x. I will take 5 as a common factor. This is integration of 1 over 5 multiplied by 1 over 1 minus x over 5. I can write it in this way, or in this form. Now 1 over 1 minus x over 5. This can be written as power series. I would say this is 1 over 5 outside, integration of sigma. The power series for 1 over 1 minus x over 5, it is minus x over 5 to power n dx. We can swap between the integration and sigma. That is 1 over 5 sigma integration of minus x over 5 to power n dx. Integration for this one, it is x or minus x to power n plus 1 divided by 5 times or 5 to power n times n plus 1 multiplied by negative sign plus constancy because this is indefinite. Where n starts from 0 to infinity. So this will be the power series representation for the given function, which is ln of 5 minus x to power n plus 1. So we can simplify to more to write it as n plus. We can write it as sigma of minus 1 to power n plus 2 multiplied by x to power n plus 1 divided by 5 to power n plus 1, because I will take this 5 inside, multiplied by n plus 1 plus the constancy. So this is a power or series representation, again where n starts from 0 to infinity. And to find the radius of convergence, we can apply the ratio test to find r. We need to find r for this one. Just apply the ratio test. Or maybe another way. One more example. If I have f of x equal to x squared multiplied by tan inverse x to power 3. So this function, which is x to power 2 multiplied by tan inverse, you know that tan inverse is the integration of 1 over 1 plus x to power 6 or x to power 3 or to power 2. So this one can be written as multiplication of the integration or x to power 2 times 1 over 1 plus x to power 6 dx. Now 1 over 1 plus x to power 6, this can be written as power series. This is equal to x squared multiplied by integration of sigma. This is minus x to power 6 all to power n dx, where n start from 0 to infinity. So this can be written as x to power 2 multiplied by sigma of the integration dx is equal to x squared multiplied by sigma integration of, it can be written minus 1 to power n and x to power 6n is equal to x squared sigma minus 1 to power n multiplied by x to power 6n, that will give me x to power 6n plus 1 divided by 6n plus 1 plus the constant c. We multiply this x inside, take x squared inside, add the powers. I will have sigma minus 1 to power n times x to power 6n plus 2 divided by plus 2, and it starts from 0 to infinity, and plus the constant c. So this is the power series representation.